As we discussed in the last video, that corrosion is a natural process and it can occur in different type of materials like concrete, wood, aluminium, steel, etc. However, presence of chromium in stainless steel generates a chromium oxide layer on the surface of the stainless steel, which protects it from the corrosion. That's why stainless steel is corrosion resistant. But wait, stainless steel is not invincible. Stainless steel is also susceptible to corrosion. Yes, you heard it right. Under certain circumstances, stainless steel can also corrode. So let's find out how and what are the types of corrosion in the stainless steel. First type of corrosion is uniform corrosion, which can occur in stainless steel. This is a very common form of corrosion. It is the most benign type of corrosion as the rate of corrosion is relatively judged and impact of corrosion can be easily evaluated. Stainless steel is generally resistant to uniform corrosion in a specific environment if the corrosion rate does not exceed 0.1 mm per year. Uniform corrosion occurs when the passive layer is destroyed on the whole or on a large part of the stainless steel surface. So this passive layer of chromium oxide destroyed due to acid or hot alkaline solution. Depending on the concentration and temperature, acid attacks the surface of the stainless steel. Hydrochloride and sulfuric acid at some concentration are more aggressive towards stainless steel. Now second one is pitting corrosion. This is one of the most dangerous type of corrosion as it can be very hard to predict, detect and identify it. This corrosion is highly localized. If the passive chromium oxide layer on the SS surface is damaged locally, pitting corrosion can initiate from that location, as the small damaged area will act as anode and undamaged protective layer will act as cathode. Then the corrosion ratio will be very high and small pit will be formed. Corrosion pits most commonly travel downwards as it cannot be identified easily. That can lead to failure of whole structure. Pitting corrosion can occur when stainless steel is exposed to environment that are rich in chlorides such as salt, and also if the stainless steel is having unwanted inclusions. For example, manganese sulfide often initiate pittings. Apart from chlorides and impurities, it can be caused by elevated temperature for extended hours and lack of oxygen on the surface of the stainless steel. Now third one is crevice corrosion. As its name suggests, crevice corrosion refers to the corrosion occurs in confined space, which creates a stagnant microenvironment. It occurs in shielded areas like under the washer, bolts, heads, gaskets and inside the threads. In confined space or in a very tight crevice, the oxygen is restricted. As the oxygen content is very limited inside the tight crevice, it prevents the oxygen to react with the chromium and generate the chromium oxide layer on the SS surface, which facilitate the corrosion attack. Compared to pitting corrosion, crevice corrosion results in large but shallow attacks. Now the fourth one is intergranular corrosion. This type of corrosion can caused by impurities at grain boundaries that formed during the solidification of alloy. It is a very rare form of corrosion. If carbon level in steel is comparatively high, which caused formation of chromium carbide at the grain boundaries, reducing the chromium content and weakening the chromium oxide layer. This corrosion occurs at temperature between 450 to 850 degrees Celsius. The process is also called sensitization and it typically occurs during welding. Now the fifth one is stress corrosion cracking. So stress corrosion cracking is generated when a metal is exposed to specific corrosive environment under tensile stress, often at elevated temperatures. It occurs because of external stresses such as expansion and contraction due to high temperatures, or it can also be results due to residual stresses generated inside the steel during the manufacturing process such as cold forming, machining, welding, etc. Stress corrosion cracking can be very hard to detect as the majority of the surface remains unaffected, but very fine crack developed in the microstructure of the metal. that can lead to more cracks. Another form of this type of cracking is sulfide stress corrosion cracking, which is associated with the hydrogen sulfide in oil and gas field. Now the sixth one is galvanic corrosion. It is also known as bimetallic corrosion. It occurs when two different metals are in contact with each other in a moist environment. Water or moisture acts as an electrolyte. In the electrolytic environment, the least corrosive resistant metal usually affects more, because the less corrosive resistant metal becomes anode and more corrosive resistant metals become cathode. That's why stainless steels are advised to be placed or worked in a separate areas from carbon steel, galvanized steel or other such materials.